Dilations. I know. We have talked about dilations a lot. We're gonna be talking about it again, in case some of you have forgotten, because you're gonna be using them mostly in the works that you're gonna be doing this week. So let's get down to the main concept. A dilation with scale factor of n and center at point C is a transformation that has center of dilation point C and scale factor n, where n is greater than 0, with the following properties. Let's get down to the notation before we talk about the properties. Take note how I read the notation. This notation right here, that's the rule. Now, D is for dilation. That's dilation. Now n is your scale factor. We're going to be talking about it as we progress through this lesson. Scale factor. And C is a point that is the center of dilation. Now, what's happening here? A dilation, we know, and we talked about it in class. A dilation is either a reduction, you shrink the figure, you make it smaller, or an expansion, an enlargement, meaning you make the figure bigger. That depends on the value of n. When the value of n is greater than 1, the dilation is an enlargement. When n is less than 1, but it has to be greater than 0 for our purpose for this lesson, because you're just in high school, it is a reduction. Okay, so those are the concepts here. Okay, so first the notation tells you that D is the dilation. Okay, stands for transformation. Our transformation is dilation. N is the scale factor. C is the center of dilation. Now, what's the center? The center is where everything starts to go smaller or go bigger. The image either is getting closer to the center or getting farther away from the center, depending on the scale factor. Now, in this figure right here, point R maps to R prime. Another notation that you need to pay attention to, the prime symbol right there. This is the apostrophe. Point R maps to R prime in such a way that R prime is on ray CR, this ray right here, this pointy line right there, and the distance from C to R prime is equal to the scale factor times the distance from C to R. So meaning R prime is either farther away from the center or closer to the center based on the scale factor. Now, let's proceed. Each length in the image is n times the corresponding length in the pre-image. So here, for example, the pre-image or the original is, let's say, 2, and this is, let's say, 6. The image of line segment XR, which is X prime R prime, in such a way that XR is 2, X prime R prime is equal to 6. You know that n, the scale factor, is equal to what? 2 times what equals 6 is equal to 3. So that's what it's meaning. The length of the image of a line segment is equal to n times the length of its pre-image. So now let's erase that because I don't want to confuse you later on. Let's proceed. The image of the center of dilation is the center itself. If there's one point that doesn't move, it is the center. So if you dilate point C, from C, the result is still to be C. Okay, that's obvious. Now, if n is greater than 1, the scale factor is greater than 1, it is an enlargement. I jumped the gun there. Proceeding, if n is less than 1 but has to be greater than 0, the dilation is a reduction. We talked about that already. Every angle is congruent to its image under the dilation. Another way of saying this is that in a dilation, the angles are preserved. Are preserved. So an angle, the measure of an angle does not change after undergoing a dilation. On a coordinate plane, the notation d subscript n describe the dilation with the origin as the center of dilation. Remember, okay, if the center of dilation is the origin, you don't have to write it down. So if you don't see the center indicated, you know that the center of dilation is the origin, or 0, 0. Moving on. Dilation on the coordinate plane. Now there are two types. One type is the dilation with the center of the origin, 0, 0, with scale factor k. Pay attention to this, because if we're doing this face to face and you're still confused about the dilation from the origin, you know how my eyes will look like. Well, the notation is, okay, the dilation of a point with coordinates x, y, with a scale factor of k, we're using k here instead of n, the scale factor, is equal to k times x, k times y. So the scale factor is k. The scale factor is k equals k. Well, the center is not indicated in the rule. The center is at 0, 0, or the origin. So it's easy when it's when the center is at the origin. The coordinates of each point in the figure being dilated is just multiplied by whatever is the scale factor. I'll give an example later. For example, well, I'll give you an example now. For example, we have the dilation of let's say negative 2, 1.5 with a scale factor of 4. Okay, we know that there's no center indicated. The coordinates of the center or the name of the point is not indicated, so the center is at 0, 0. So we have, okay, what's the scale factor? The scale factor is 4. So now the result of this dilation would be just 4 times negative 2. It's going to be 4 times negative 2 is negative 8, 4 times 1.5 is equal to 6. Very good, very good. You're very good with your math. You can multiply. Very good. Now, what about if the center is at any other point, not the origin, given a scale factor? Well, our rule changed a little bit. So for example here, the dilation of the point with coordinates x, y with scale factor k centered at a, b will be equal to, that's a lot of figures there, is equal to a, the x coordinate of the center, plus delta x. I'm going to be talking about the delta x and delta y proceeding, b, the y coordinate of the center, whatever that is, plus delta y. Well, the formula for delta x and delta y are over there. Now, it's easy if you either have this rule written down, so you can pull it out and use it when the center is not the origin, because though it looks like complicated, it is really not. So moving on, let's take an example. Let's say the dilation of a point 5 comma negative 2. Let's say we're dilating a figure and one of the points has the coordinates 5 comma negative 2. The scale factor is 2 and the center is at negative 1 comma 2. So let's see, let's indicate that this is our A and that's our B. So you know you have your A, B. So that's what's going to be using. This is our X. This is our Y. So now let's first find delta X. So let's find delta X. We're looking for the image of 5 comma negative 2 under this dilation. So let's find delta X. So delta X is equal to X, which is 5, minus, okay, the X coordinate of the center, which is negative 1. Negative 1. Okay, and we're multiplying that is equal to what? 5 minus negative 1 is equal to 6 times K. Okay, times K, which is equal to 2. That's equal to 12. That's our delta X. Okay, so delta X is equal to 12. Okay, now let's find delta Y. Delta Y is equal to, well, what is Y? Negative 2 minus, okay, the Y coordinate of the center, which is B, that's 2, minus 2. Ooh, negative 2 minus 2 is equal to, what's negative 2 minus 2 is equal to negative 4. You multiply that by the scale factor. The scale factor is 2. That's equal to what? Negative 4 times 2 is equal to negative 8. That is our delta. That's our, yes, that's our delta Y. So we have the delta X and we have the delta Y. Delta X, delta Y, delta Y. I don't know why this pen is jumping. All right, so now let's find X prime. This is the image of this. This is going to be the X coordinate. Okay, it's going to be A plus delta X. Let's say that's our X prime. This is our Y prime there. Okay, so it's going to be X prime. Okay, is equal to, well, let's just add. Okay, what's A? Negative 1. That's your A. Negative 1 plus, okay, what is delta X? Plus 12. Plus 12 is equal to, negative 1 plus 12 is 11. That's easy. Now the Y prime is equal to what? 2 plus negative 8 is equal to negative 6. All right, so now, meaning we can now write our answer. It's gonna be the dilation, blah blah blah, is gonna be D. Okay, the dilation of, okay, of 5 comma negative 2 with a scale factor of 2, center at negative 1 comma 2 is equal to what? That's our X prime. That's gonna be 11 comma Y is negative 6. That's our answer. Okay, so step by step. Step 1, find delta X. Step 2, find delta Y. Now after you do step 1 and 2, find the X coordinate you're looking for, the image that is X prime. Step number 4, find the Y coordinate of the image that is Y prime. And of course, after that, just assemble your answer so that it looks like a coordinate. pair. So gonna be 11 comma negative 6. Replay this video as you see fit. In case you need to be reminded, you're gonna be using this concept in the upcoming example. So stay tuned. Watch the next video.